Right, good morning, everybody. We are on to the fourth lesson of the Bible and evolution this morning. So this session is session number 4, and we will look at the witness of Mount St. Helens on this whole topic of the evolution. Okay, so this is Mount St. Helens. The picture on top is before, and then the picture below is after the May 18th, 1980 eruption. And you can see that there is a massive difference in the two. Okay, the picture on top is dated May 17, one day before. And the picture below is September 20th, same year, 1980, which is a few months later, the same place. So what happened? Well, let's just take a look at some of the pictures so that when we discuss the idea of the changes connected to evolution, and we will be able to understand and appreciate better. So this is a picture of the guy, the volcanologist, David Johnston. He was there at 8:32, right? And when the volcano erupted, he radioed this message: Vancouver, this is it. Sadly, he did not survive the eruption, and that's why later on they renamed this place Johnston Ridge in honor of him. Okay, yeah. So these are some of the pictures. St. Helens erupts on May 18, 1980. Another picture, the plumes of smoke you can see. And then this ash plume billows from the crater at the top, hours after its eruption. And the column of ash and gas reached 15 miles into the atmosphere, and it deposited ash across a dozen states. And the clouds move over this Ephrata airport in Washington. Even on the next day, May 19, it did not clear. And communities across Washington were covered in 3 to 5 inches of this very fine ash particles. So 3 to 5 is almost half a foot. You can imagine that much ash. And this is the flooding that took place, a house submerged along the Toutle River. And the area streams and rivers rose very quickly as ice and snow on the volcano melted instantly. So this is something that you can probably have to imagine for Noah's flood, right? One of the things about Noah's flood is the ice and the snow, okay, actually brought down the temperature of the planet so that we have the ice age. Okay, so one of the side effects of the Great Flood was the lowering of the temperature such that you have the ice age, and that's where we have the glaciers and the North and the South Pole that God has separated. And this is a blowdown of trees, the eruption viewed on August 22nd, so that is about 3 months later, right? You can see the whole place, all the trees are down, except the very top up here. And here's another picture of the tree trunks. The trees are blown down, and you can see the 2 geological survey scientists, lower right at the bottom here. This is to give you a scale where you have 2 human beings, right? And so you can imagine how huge the place is with all the trees knocked down, and you compare the height of the 2 men with the length of the trees. So the trees were really very tall, but they were all blown down, blown over. And you can observe the direction of the blast shown here from left to right. Yes, and so you can see the alignment of the trees actually. And they estimated over 4 billion board feet of usable timber that you can use to build 150,000 homes destroyed. just by that catastrophe. Then you have the crater here left at the summit after it lost more than 1,300 feet of elevation. So it's supposed to be 1,300 feet higher, but now it looks like somebody scooped out a big chunk of the top so that it no longer looks like a mountain, a mountain peak anymore. And the surrounding landscape is still steaming. And that's where you have the steam rises from hot water in a river following the aftermath. And this is the next day on May 19, 1980. So you can see there are very extensive damage and extensive impact across the whole area there. And this is another picture of the trees, or the denuded trees. They are like matchsticks. And you can see that the whole landscape is now changed, right? And this is 2 days later on May 20th, 1980. And this is Spirit Lake, right? And you can see the whole landscape is all no longer someplace livable in that sense. And Mount St. Helens erupts again in July the 22nd. So 2 months later, it erupted one more time. In fact, over the next 4 years, there were a few eruptions. And then you have a Washington State geologist and a reporter walking the crater in May of 1981. So 1 year later, after the volcano exploded. And they were near the steaming lava dome with a snow-covered crater wall beyond. So this part here is still snow-covered. And that's 1 year later. Okay, so what this catastrophe shows us is it doesn't take millions of years for major change to happen. When you talk about evolution, they always talk about how things evolve over millions and millions of years. But down here, no. It shows that that is not the truth. Pre-1980, Mount St. Helens with a view of Mount Hood to the left. Okay, and the picture is taken looking in the southerly direction. And then post-1980, the same place, very much the same angle, right, with the view of Mount Hood to the left also. Picture also taken looking in the southerly direction. So they are pretty much the same angle, and you can see a huge difference. Yes, down here is really like your ice kacang with toppings on the top. But down here, somebody has scooped a big chunk of the top. Yeah, and you look at the area around it, it's all like moonscape. And satellites in orbit and scientists on the ground, they still monitor the mountain and track the recovery of Mount St. Helens. And this image shows a 3D, three-dimensional view of the mountain looking toward the southeast on April 30th, 2015. So this is much, much later, about 35 years later. Okay, so what we can understand from the witness of Mount St. Helens is we have actually been brainwashed in evolution. See, people throughout the world are indoctrinated by evolutionists to believe that layers like those that we see at the Grand Canyon took millions of years to be laid down. The idea that the Earth is billions of years old is foundational to evolution. So that is a very important concept in evolution, that the Earth, the Earth is billions of years old. But what happened at Mount St. Helens is a powerful challenge to this foundation. Here on this diagram, you can see they give you a difference. Yeah, this is the pre-1980 summit. And after the eruption, it has actually dropped all the way so that now there's a crater here and a lava dome, right? So you have a picture of the lava dome and a crater glacier. And then you have the landslide deposit down below, okay? And Lewitt Falls, where later on you'll see that the canyon actually forms there. Yeah, so you have Grand Canyon. People thought that it took millions of years to form, but you will see that at Mount St. Helens, a canyon can actually form very fast, just within a day. Okay, so in fact, it makes one realize that the world flood with lots of volcanic action and other forces operating could explain features like the Grand Canyons forming within a very short time. And this really does show that one can logically accept that the flood of Noah's day could have accomplished extraordinary geologic work, such as laying down sediments in huge quantities all across the globe, just like we see in real life. But here at Mount St. Helens, the fiery event took only 6 minutes. You compare what people thought took millions of years. Yes, there was its own version at Mount St. Helens in just 6 minutes. So that really, you can see it really cuts the scale down from millions of years to 6 minutes. Okay, this is the testimony of an apologist, Ken Ham, on 1st of June, 1993, who said, "I had never realized geology could be so exciting. But there was more to come. At Lewitt Canyon, they looked 100 feet down. And what did they see? Hard rock had been eroded by mud flows in short periods of time. You see, huge hard rock, but it just disappeared. I had not perceived before that mud could cut through hard rock in a short time. Okay, but then I have heard of a tool which engineers use to cut steel, which basically uses water under pressure. So you imagine using water under pressure, it's possible to cut steel. So down here, mud flow could cut through hard rock. Okay, so it takes a catastrophe like this for people to suddenly discover something that we don't normally see in our lifetime. So what I came to understand was that water, mud, and steam, etc., under the right conditions, like a catastrophe here, can produce results in a very short time that evolutionists are telling the world have to be interpreted as having taken millions of years. So this is very, very significant discovery that we can now use based on observation, scientific observation. So we have 7 wonders of Mount St. Helens volcanic eruption. And we're going to look at these today. Mountain rearranged beyond recognition in 9 hours. Just 9 hours, you see the mountain is totally different. And then the second thing is the layered strata, you know, the like your kao ting kueh, your kueh lapis, all the layers formed in just 3 hours. Doesn't need millions of years. Badlands formed in 5 days. Canyons formed in 5 months. In fact, it can take 1 day, but then after that, what happened within the 5 months? Then the river systems were formed in 9 hours. You know, the rivers, they all changed. Then sinking logs look like aged forests in just 10 years. And from there, we have a new model for quicker coal formation. People say coal takes millions of years to form. Not anymore. Using science, we can see that it's not necessarily so. Okay, so let's take a look at these things, these points, the 7 wonders of Mount St. Helens. First one, mountain rearranged beyond recognition in 9 hours. Yeah, St. Helen was cone-shaped and snow-covered, towering over heavily forested deep ravines with a crystal clear lake to its north. That would be Spirit Lake. And much of 1980, magma is lava before it explodes up from the volcano. So magma began moving up into the mountain, wedging it apart. It's starting to cause the mountain to kind of buckle under pressure. And on May 18, the powerful earthquake at 8:32 a.m. caused the north slope to plunge into the rivers, or rather the valleys below, releasing the pressure within with a lateral means straight from the side, northward fan-shaped explosion. So you can imagine it's just like a window just blowing out. Yeah, blowing up and a fan-shaped explosion. And this initial 8-minute blast destroyed 600 square kilometers of forest. 8 minutes destroy 600 square kilometers of forest. Here's a picture of a timber blowdown on June 8, 1980. So about 1.5 months later, this is what it looks like. Some pictures. So this is a very nice prior to 1980 picture. The valley north of Mount St. Helens, okay, with all the majestic old growth forests. Yeah, and this one, the next picture, no trace of the pre-eruption forest. Let's compare the difference. The forest is totally gone. That is summer 1980. And this is a close-up view of the forest north of the volcano before the eruption. And it just became bare after that. And this is now the same view, you know, the before the eruption. This is the same view. The original surface lies beneath more than 45 meters of landslide and pyroclastic flow deposits. And this is 1 year after eruption. So you can imagine the forest is actually buried under 45 meters of landslide and mud flows. Right? So the land has been elevated because the top of the mountain collapsed and the lava and everything all spread all across the landscape. So we see the mountain continued to erupt until evening, expending the power of 20,000 Hiroshima-class atomic bombs. So this is a picture of how powerful the bombs can be. In those 9 hours, the top 1/4 and entire center of the mountain disappeared, right? The top 1/4. So it spread out all across the landscape and buried the forest. Yeah, leaving a vast, gaping, horseshoe-shaped crater. Deep ravines were filled. 75 meters of material was deposited on the bottom of the lake. So all that was transferred to the lake. And the river that drained the north and northwest sides of the mountain was buried under an average of 45 meters of deposit. So in just 9 hours, the whole region had become a hideous, lifeless moonscape. Looks almost like the moon now. So for 150 years, geological evolution minimized the role of catastrophic events. Yeah, evolution thinks that catastrophes either don't happen or they don't matter. Supposedly, the enormous geological change produced by this 9-hour eruption, and it's just a minor volcano, would, according to evolution, would take 1,000,000 years of gradual change. Yeah, but in reality, it just took 9 hours. All right, so this is this really big major discovery that contradicts evolution, right? Cuts down the premises of evolution that things on Earth, landscapes and so on are formed over millions of years. Okay, second wonder of Mount St. Helens is the layered strata was formed in just 3 hours. And naturalists have long claimed that stratified layers, like those found in the geological column, actually accumulated over vast periods of time, and these layers represent season variations. Many seasons they cause all these layers. But then Mount St. Helens deposits have demonstrated that catastrophic processes are able to create these geological formations in a very short period of time. And in this photograph, we have 3 distinct layers formed from 2 separate eruptions. Okay, so May 18 was one eruption, but there was another eruption later on. And this cliff face shows the sediment deposited by eruptions and includes a 7.6 meter deposit of layered sediment. So you have 3 very distinct layers, 1, 2, 3 here. Okay, so you form your cheesecake or your whatever it may be. And for scale, here's a human being there. June 12, 1980, volcanic ash flows moving at nearly 90 miles per hour or 150 kilometers per hour, deposited a layered volcanic ash bed 25 feet or 7.6 meters thick within just 3 hours. Okay, so this doesn't have to take millions of years to form. Now, the eruptions at Mount St. Helens triggered several different earth-shaping forces. You have the original blast of air followed by landslides, and then volcanic ash flowing on the ground. You have mud flows, and then you have steam water, and you have falling volcanic ash. So you have hot and you have cold at the same time, actually. Even the water in nearby Spirit's Lake was temporarily pushed out of its basin because of all these things kind of like flowing in. And then the water came crashing back into place after that. And these catastrophes produced complex sediment layers up to 600 feet thick, which is 180 meters. So here you have the strata in east wall of the crater. Yeah, and this is recent history. Yeah, it doesn't need us to go back all the way to the flood of Noah, but something more recent, just 1980, that is so by now 42 years ago, and something amazing like this. March 19, 1982, another explosive eruption created destructive mud flows that cut canyons up to 43 meters deep in a single day. And Little Grand Canyon of the Toutle River, seen here, is a 1/40th scale model of Grand Canyon. So 1 out of 40 parts, right, is just formed in a single day. Okay, so down here, you will see the picture. You can't really identify. We will look at it later. Come back again here. All right, the same area, Little Grand Canyon was carved by a catastrophic mud flow within 1 day. This is the picture, right, of the landscape. On March 19, 1982, you have a small eruption, melted the snow. It caused a mud flow, and the mud flow, remember, it can punch through hard rock, right? So it punched through hard rock and it eroded a canyon system up to 140 feet deep. So here's a picture of the canyon, the flow, the mud flow here. Okay, this part here is actually this here. Okay, the same picture. Just that this is a close-up of this area. We will see this again in a few slides time. Okay, third wonder is the badlands were formed in 5 days. Yeah, badlands. What is badlands? Badlands are extensive tracts of heavily eroded, uncultivable land. So land that has been, can I say, eroded or damaged in that sense, with now little vegetation. So all the plants, all the trees, and whatever you have, they've all been washed away. A type of dry terrain where softer sedimentary rocks and clay-rich soils have been extensively eroded. Okay, so you have eroded ridges, peaks, and mesas. All these ups and downs like little slopes and mountains. So badlands topography is found in the southwest and in South Dakota. It occurs where loose material has been eroded in areas of rock structures, leaving a jagged but picturesque landscape. Okay, the standard explanation for such landforms is that water over centuries washed away the loose materials, leaving freestanding towering rock patterns. So all the, the strange shapes that are there, supposedly, according to how evolutionists explain, it's water over centuries, washing away the loose bits until the funny shape just stands there. All right, but not so in Mount St. Helens. The massive landslide carried huge amounts of ice and snow with it. Okay, so you have ice, snow, and you have hot. You have hot and you have cold, burying them in the deep valley to the north. Throughout the day, 10 meters of 290 degrees Celsius ash was also deposited. So you have the hot, you have the cold, which quickly melted that ice, causing it to flash, to steam, because the temperature is very high. Yeah, this is the same energy process that caused explosions up in the mountain throughout the day. And that's how you get the badlands being formed. Water expands 1,700 times when it turns to steam. When this happens instantaneously, straight away, then you get an explosion. And eventually similar explosions, all the water was used up, and that's where you will find all the badlands, all the funny shapes happening. Okay, so you have melting ice and snow mixed with rock and ash, producing debris-laden floods called lahars, which are actually mud flows. So remember this word, if you see lahars later, it just simply means that the mud flows very powerfully. Now, when the red hot ash covering the buried ice and snow in the valley caused the ice to melt and flash to steam, something called steam explosion pits up to 40 meters deep were formed. They had nearly vertical sides, so straightforward, okay, until gravity collapsed them to produce a rill and gully effect, one of the features of badlands topography. Rills are small gullies. And the great badlands features in the US could also have been produced by catastrophic forces and some by volcanic action. Here's a picture, the largest steam explosion pit in the process of formation on May 23rd, 1980. So that is only a few days, less than a week, looking east. The pit is 2,300 feet long from east to west, 1,000 feet wide from north to south, and extends 125 feet deep into the pumice deposit of May 18. The volcano is to the right of the photograph. The southwest shore of Spirit Lake is in the upper left corner. So this side, southwest shore. Okay, here's a big picture, close up. Largest steam explosion pit viewed from the east on June 18. The pit, as I said, is 2,300 feet long, has a flat floor of pumice deposited by the volcano's June 12 eruption. So the valley was covered with ash and boulders. Down here, it says there's supposed to be a pickup truck 2 years after eruption, but sorry, I couldn't find the pickup truck. You go and take a look at it yourself later on. Okay, so the runoff from rain and snow melt carved deep gullies in the valley north of the crater. This picture, right? So you have the badlands forming as well. The fourth wonder is that canyons were formed in 5 months. Actually, it can already be there in 1 day, but over the 5 months, you see that 2 canyons were formed by mud and pyroclastic flows, establishing drainages for the 1.5 times 2 mile crater. And the primary drainage step canyon is up to 200 meters deep. To the east is Lewitt Canyon. Both canyons cut through 30 meters of solid rock. And creeks flow through each canyon. Now, you talk about typical evolutionary explanation. A creek flows slowly forms a canyon over vast ages. You know, the little river through your Grand Canyon. And here in this case, it would be Mount St. Helens. That little river is supposed to form the canyon over vast ages because it takes a lot of time to wear off the soil or the sediment. Yeah, it's supposed to be millions of years. But here, they were formed quickly because of the mud and pyroclastic flows that were very forceful. Then a stream began to run through them. Now, textbooks say the most spectacular canyon in the world, the Grand Canyon, was formed by a steam erosion over 100 million years. Stream erosion, not steam, sorry, stream erosion. So now scientists who specialize in geological erosion believe it was formed rapidly, just like these canyons at Mount St. Helens. Okay, so this is where you have the canyon that I showed you just now, the 2 pictures. This is the landscape. I circled this part here to show you this. This part here, if you look carefully, is actually this picture here. Can you see? This part here is actually this one up here. And then this part here is here. You can take this as a reference point. This part here is here. Okay, so this part here is actually here. And so down here is actually the mud flows. And this is a newly formed canyon. Right, you have a westward view looking down the North Fork of the Toutle River, August 1984. So 4 years later, and you have a detailed view of the deep canyon in this picture, which is on the right side of this photograph. And here you have the deeply eroded gorge, photograph taken in August 1983. And the man there provides the scale. There's no little drain. Yeah. Okay, so we have the origins, the same place. Yes, the same picture there. Westward view of the canyon, formed rapidly. August 1984, picture taken. And on this side, you have the cliff at the base of north slope of Mount St. Helens. Again, the person gives the scale. The cliff was eroded by water, mud flows, and pyroclastic flows since the May 18 eruption. Okay, so you can see water, mud. That's it. Okay, and it can form such amazing features on the landscape. Lesson about catastrophe. Small creeks now flow through these deep canyons. So you have little rivers, little water flows. In other places, geologists assume creeks cut the surrounding canyons very slowly over a long period of time. But at Mount St. Helens, they know the canyons formed first and formed extremely rapidly. The creeks are there because the huge amount of water has already flowed away. So now come back to, in that sense, ordinary day, ordinary living, the water goes to this trickle. But it was originally a huge flood of water and mud. Okay, and it carved out this, this river system that parts form a new river system. Okay, now we apply this to the creation model. Yeah, well, we connect it to creation. We've been talking about evolution and comparing it with what happened at Mount St. Helens. Now we compare it and apply it to creation. Rapid canyon formation. So geologists, they commit the error of assigning long time scales to the erosion of deep canyons. And the canyons include the Grand Canyon of Arizona, could have formed very rapidly during and immediately after the flood. Right? Remember, the water of the flood were actually covered the highest mountains. So can you imagine that water is a lot more than what you found at Mount St. Helens? And that kind of amount of water can do massive damage compared to Mount St. Helens. Right? So what happened at Mount St. Helens demonstrates that the sudden release of water, huge flash flood, you know, even today we can imagine flash floods, which are nothing compared to the Grand Canyon or Mount St. Helens and the flood of Noah. Okay, our flash floods nowadays can already cause a lot of damage. So imagine this sudden release of water at Mount St. Helens can cut canyons rapidly, even through hard rock. Special destructive processes are in play during catastrophes, not during the normal everyday life. And these we don't see every day. The fast-flowing mud and water pick up rocks. See, to them, to the fast-flowing mud and huge amount of water, the rock is just nothing. And these rocks scratch the bedrock surfaces and they leave behind grooves and striations, you know, scratch marks that to us look like layers, often mistakenly ascribed to grinding, slowly moving glaciers. So we think they're actually caused by glaciers, but actually not necessarily so. It can just be fast-flowing mud and water that pick up rocks to go and scratch all these grooves and striations. When the mud and water flow fast enough, it can cause, okay, new word, cavitation. And what is cavitation? It's a process that generates vacuum bubbles that implode. So boom, boom, and inflict hammer-like blows, you know, and these blows pulverize rock, so they can damage the rock. Such rapid erosion processes would have operated, of course, on a much grander scale if you talk about the Noah's flood. Okay, so now this is helping us to put in perspective, but a smaller picture of what the great flood of Noah would have been like. But this is really chicken feet, nothing compared to that. View up Lewitt Creek into the crater. And there you have that little creek, yeah, that people think take millions of years to form the canyon. Actually, it is the canyons already formed. And then the creeks are the leftover drips of water. Okay, so this is where you have the river system formed in 9 hours because of the huge amount of rain of water. I'm thinking of rain because Australia got flooded just last night on the news. All right, big areas are flooded underwater until the houses are submerged up to the rooftop. So imagine the landslide of May 18 buried the river and the highway to Spirit Lake to an average 45 meters. So not surprising if you go and look at your news, Australia and those countries where they have really massive floods, you cannot see the roads anymore. You cannot see the rivers, you cannot see the roads, you cannot see the highways. You probably cannot see some of the cars. In fact, most of the cars, if the flood already reached almost the roof of the house. Yeah, so imagine here, the landslide buried the river, buried the highway, averaged 45 meters. So it also buried most other drainages in the 60 square kilometers of the upper Toutle Valley and plugged the valley's mouth. It carried all the mud and so on and blocked up the valley's mouth. For 22 months, no established path for water to the Pacific Ocean existed. So it blocked up the river so that the river could not reach the ocean, the river water. This picture, you see a river of mud and debris from the eruption. It chokes the Toutle River basin under a mass of mud and debris running 125 to 600 feet deep. And the 1980 blast destroyed almost everything within sight of the mountain. Note the rows of downed trees. Okay, the trees are here on the hillside at right that were laid down by the blast of the eruption and stripped of all limbs and foliage. So no more branches, no more leaves. Then on March 19, 1982, so 2 years later, an eruption melted a large snowpack that had accumulated in the crater over the winter. So another eruption. The waters mixed with loose material on the mountain slopes, creating an enormous mud flow. And in 9 hours, when there was nobody to watch, the mud flow carved an integrated system of drainages over much of the valley and reopened the way to the Pacific Ocean. So now there's a way through the Pacific Ocean. The drainages included at least 3 canyons 30 meters deep, and one was nicknamed the Little Grand Canyon of the Toutle because it is a 1/40th scale model of the Grand Canyon. Here's a picture. You see the mud and debris spewed, clogged every river and stream, knocked out the bridges, and closed every road in the downstream flood. Here you have the crew of a National Guard rescue helicopter. You don't see the helicopter because it's actually reflected. This part here is the reflection. I think the person who took the photograph, this part was a reflection in the glass as he looked out to take this photograph. Okay, so this is reflected up here as they search for survivors of the eruption. Mud and debris have swept down the Toutle River, wiped out the bridges and sections of highway. So now no more roads because it's all been wiped out. You can't, okay, you can see down here, this part here is still the leftover road, and then the rest up to here, you cannot recognize where is road anymore. Okay, lesson about catastrophe. Much water or mud, I add in the word fast flowing, yeah, because water or mud by itself is useless. It must be fast flowing, accomplishes rapidly what a little water or mud takes an eternity to accomplish. So you have the concept of the evolution here. If it's eternity to accomplish is a little water or mud. But when you talk about catastrophe, mud flowing, that is fast flowing, then everything happens very fast. So apply it to our creation model. According to what we find in the Bible, evolutionary geologists assign long periods of time to the formation of the 40,000 square kilometers channeled scaplands of eastern Washington. In the 1970s, they finally acknowledged that this vast geologic formation, which includes the Grand Coulee, was formed mostly in 2 days as a result of a catastrophic event. Catastrophic events best explain the great erosionary formations on Earth's surface, and the histories of nearly 300 people groups speak of an event adequate to the job, the global flood. So that's to say that 300 human races across the world actually have some memory of a global flood. Okay, so that is a confirmation that the flood really did happen, because you have 300 people groups across the world having some kind of records or memories of something like that. Okay, the sixth wonder, you have sinking logs look like aged forests in just 10 years. All right, you have this picture which I showed you just now. And here's another picture we'll come to later. As the site of the volcano slid into nearby Spirit Lake, it pushed a wave of water. You know, the water that came down, it splashed, and because it's such an amount, it pushed the water into the neighboring forest, and then it dragged many logs back into the lake. As the massive water pushed out of the lake, then when it flowed back, anything there that is caught, it is pulled back down into the lake. And by late afternoon, over 1 million logs were floating on the lake. Many were actually floating upright. Even though the roots were broken off, the bases were still thicker and denser, causing the logs to float upright. Many logs subsequently sank to the floor of the lake, still upright but rootless. Indeed, it was estimated that 20,000 upright, fully submerged logs were sitting on the floor of the lake by August 1985. So that's 5 years later. They looked like a forest of trees buried in mud. Radar and scuba divers found that many logs had become buried by more than 1 meter of sediment, while others were still resting on the floor of the lake. This is a picture that is taken by sonar. This is a sonar image of the logs in the lake, and you can see that they are actually upright. Yeah, they sank to the floor of the lake, but upright. Okay, later on we'll have a little note on why they were upright. And they are called vertical floaters. Yeah, here you have a picture of the vertical floaters. And this is September 1982, 2 years later. By late afternoon, over 1 million logs were floating on Spirit Lake. And September 82, the first scientists to reach Spirit Lake by road found upright floating logs. So many were still lying on the side, but then there were other logs that started floating upright, vertical floaters. Okay, so lesson about catastrophe. You have a picture here, the floating one on the side, and then upright, and then sank down. In just 5 years, many layers of upright trees were buried. If geologists had never observed what actually happened, they could easily have misinterpreted these upright buried logs as representing multiple forests that grew at different periods over many thousands of years. Okay, so a lot of those things that we are seeing now have been interpreted as thousands of years, but now we're beginning to see that they can be very fast. And this is in fact how they interpret the petrified upright logs at Yellowstone National Park, Specimen Ridge, you know, where they have these upright petrified tree trunks. and they thought it took many thousands of years. So many logs floated upright before they sank, and they formed deposits of rootless tree stumps, similar to the petrified forest in places like Yellowstone National Park. So here's a picture of Yellowstone National Park upright petrified tree. So not surprisingly, now we know it doesn't have to take millions of years. So application to the creation model, the petrified forest and polystrate fossils. We'll talk about polystrate fossils another time, but many of the petrified logs at Yellowstone are upright and missing their roots, just like the ones at Mount St. Helens. This shows that the fossilized upright logs in so-called petrified forests could have come from logs that were floating during and after the flood and then sank to be buried upright in sediments. This phenomenon would explain another type of fossilized upright logs called polystrate fossils. So they are actually logs that are upright, okay? Polystrate fossils. And they penetrate multiple sedimentary layers. So remember just now the Kueh lapis effect, they penetrate multiple sedimentary layers, which can be laid very fast over hours or days. Yeah, it doesn't have to take millions of years. And these two must have been floating on the flood waters and buried rapidly in flood sediments. So now we're seeing the Great Flood in perspective of something just 40 years ago. Yeah, the catastrophe just within our lifetime actually helps us to see how things in the Great Flood could actually have been real and happened. The seventh wonder is the new model for quicker coal formation. You have the enormous log mat floating on Spirit Lake. It lost the bark and the branches. Remember, you see all the tree trunks, no branches, no leaves. All these were rubbed off by the abrasive action of wind and waves. Scuba investigations of the lake bottom subsequently revealed that sheets of bark intermingled with volcanic sediments had formed a layer of peat more than 1 meter thick. And together with broken branches and root materials, the sheets of bark gave the peat a coarse texture and a layered appearance. So like many layers. And this Spirit Lake peat resembles certain coal beds of the eastern United States. Oops, sorry, forgot to take a look at the picture. You have the logs float there, right? So the view is to the south with Mount St. Helens in the background. Now coal, what we learn is coal can be formed quickly under the right conditions. The formation of artificial coal was not nearly as difficult as many of us imagine. Okay, even nowadays we can make coal. We don't need thousands or millions of years. So another lesson, we will look at that. The right plant material could be transformed into coal in less than a month. Yes, under the right amount of heat and pressure, which we have when we have a volcano. Lesson about catastrophe. The Spirit Lake peat accumulated in just 5 years and is texturally and compositionally similar to coarse content of bed coals, which secular geologists believe need many thousands of years to accumulate. Now, here's actually what happens with the vertical floaters. Since roots are designed to absorb water, the remains of the roots on the floating logs soaked up water from the lake. And then this caused the root end to sink because it got heavy. And the log tipped up to float in an upright position. And when the log soaked up even more water, that's when it became even heavier. It sank and landed on the lake bottom. So that's how you can have it standing at the bottom of the lake. Application to the creation model. So we relate it to the Bible, rapid coal beds. Many geologists claim that coal beds formed by the very slow accumulation of organic material in vast swamps where the plants grew in place. By slow accumulation, they estimate about 1,000 years needed to form just 1 inch of coal. Okay, I'll skip the technical information, but what we have is the lesson from Spirit Lake is that coal beds can and do form very quickly due to the catastrophic destruction of forests, not the slow, gradual growth of plants in swamps. The flood would have destroyed the earth's forests in a matter of weeks. And the floating, jostling logs would produce bark that then sank to form most of the earth's coal layers. So it is the bark that form the coal layers. Okay, okay, so we have the witness of Mount St. Helens. Yeah, the witness of Mount St. Helens. The 1980 eruption of Mount St. Helens provides a rare opportunity to study geologic processes at work. Within just a few months, catastrophic processes from the eruption produced changes that scientists assumed required many thousands and even millions of years. The volcano, therefore, challenges our way of thinking about how the earth works, how it changes, and the time scale we are accustomed to attaching to its formation. So also, the environments returned to full health in just a few years. Okay, so the environment includes the animals, and it doesn't take decades or centuries. The eruption and its aftermath challenged and still challenge today the slow and gradual interpretation of the accumulation of sediments, the erosion of landscapes, and the recovery of environments. Okay, so we see that many of the things that would have happened because of the great flood of Noah's time, right, would have contributed to the things that we see around us on planet Earth, and that is exactly what happened on Mount St. Helens. So these processes and their effects, they allow Mount St. Helens to serve as a miniature laboratory. Okay, so we're getting to see something that is observable, like a science experiment, to verify the great flood of Noah. People say it's not true and it couldn't happen. And now we get to see a very small scale of that. And it becomes a laboratory. And we see two major truths that were previously unverifiable by observation. But now we can observe, right? And scientists have been observing for the past 40 over years. The first thing is this catastrophe challenged the uniformitarian ideas. Remember, as uniformitarian, that the rate of changes, the processes of change on Earth, on planet Earth, they are very gradual and they are very consistent, and they take a long time to cause all these wonders to happen, right? Even millions of years. But now we see that those uniformitarian ideas being challenged. And those are the ideas that form the foundation for Darwinian evolution. Okay, evolution, next session, next week, evolution, it's about time. It's about time. So catastrophes that we can observe, something that is useful for us to relate to in our lifetime, now allows us to challenge the concept of evolution and its its concepts. Okay. Now, second major truth that this disaster is good for is it provided invaluable clues to help us therefore understand the cataclysmic power of the Genesis flood. Okay, so while it disproves what people call science in the form of evolution, it actually supports and helps us to understand that very damaging power of the Genesis flood and the biological designs that help plants and animals repopulate the earth after the flood. Okay, so next week we will look at this whole concept of time, and next week we'll relate it back to the Bible about the concepts of time. Okay, right, that's it for today, unless you want to look at a video. Okay, this video may or may not be published. Let me see. Okay, let me stop share for a while. Let me also pause the recording.